Under our feet, a remarkable world thrives. This is the world of ants, creatures often overlooked but endlessly fascinating. Ants are found in almost every corner of the globe, from the lush rainforests to the arid deserts. Their colonies, complex and highly organized, are a testament to the power of collective living. They are master architects, skilled farmers, and formidable warriors. These tiny creatures, despite their size, play a vital role in maintaining the balance of our ecosystems. In this exploration of the ant world, we'll delve into their diverse species, their remarkable lives, and the crucial role they play in the web of life. The secrets of the ant world are slowly being unveiled by scientists, revealing astonishing insights into their behavior, communication, and ecological significance. There are estimated to be over 12,000 species of ants worldwide, each with unique characteristics and roles. From the minuscule pharaoh ants to the formidable army ants, the diversity of the ant world is astounding. Their success lies in their remarkable adaptability and social structure. Ants belong to the order Hymenoptera, which also includes bees and wasps. Their colonies, often underground cities, are a marvel of engineering, with intricate tunnels, chambers for brood rearing, and even designated areas for waste disposal. The life cycle of an ant, from egg to adult, is a fascinating journey of metamorphosis and social development. Let's embark on a journey to uncover the secrets of these tiny architects of nature. The ant world is a tapestry of diversity, woven with thousands of species, each a unique thread in the intricate web of life. Scientists estimate that there are well over 12,000 ant species on Earth, and some believe the actual number could be closer to 20,000. This astonishing diversity highlights the remarkable success of ants in colonizing and adapting to a wide range of habitats across the globe. Each species has its own unique characteristics, from the size and shape of their bodies to their social behaviors and ecological roles. Some ants are minuscule, barely visible to the naked eye, while others, like the giant forest ants of South America, can grow to over an inch in length. From the lush rainforests to the harsh deserts, ants have carved out their niches, playing vital roles in maintaining the balance of ecosystems worldwide. Ants are found on every continent except Antarctica, colonizing a diverse range of habitats from tropical rainforests to temperate woodlands, grasslands, and even deserts. Their distribution is a testament to their remarkable adaptability and their ability to thrive in a variety of climates and ecological conditions. However, the greatest diversity of ant species is found in the tropics, where warm temperatures and abundant resources provide ideal conditions for their growth and proliferation. Tropical rainforests, with their multi-layered vegetation, diverse plant and animal life, and year-round warmth and humidity, are particularly rich in ant species. These forests provide a wealth of food sources for ants, from nectar and fruits to insects and other invertebrates. The complex structure of the rainforest offers a variety of nesting sites for ants, from hollow twigs and branches to underground chambers. In contrast, ants living in temperate regions have evolved to cope with seasonal changes in temperature and resource availability. The tropics are a hotbed of ant diversity, with an estimated 2/3 of all ant species found in these warm, humid regions. The abundance of resources and year-round warmth provide ideal conditions for ants to thrive. From leafcutter ants of South America to weaver ants of Southeast Asia, the tropics showcase incredible ant variety. The sheer abundance and variety of food sources support high ant diversity. Tropical forests teem with nourishment for different ant species. Warm temperatures and high humidity favor ant activity and colony growth. While the tropics boast the greatest diversity of ant species, ants are remarkably adaptable creatures, having colonized a wide range of habitats from the lush rainforests to the harshest deserts. In these extreme environments, ants have evolved an array of adaptations to cope with challenges such as extreme temperatures, water scarcity, and limited food availability. Desert ants, for example, have developed remarkable adaptations to survive in some of the hottest and driest places on Earth. Some species, like the Saharan silver ant, have a highly reflective exoskeleton that helps them to withstand the intense heat of the desert sun. Others, like the honeypot ants of North America, have specialized workers that store large amounts of sugary liquid in their abdomens, providing a vital food source for the colony during times of scarcity. In colder climates, ants face the challenge of surviving freezing temperatures and limited food availability during the winter months. Beneath our feet, hidden from view, lies a network of intricate tunnels and chambers bustling with activity. This is the domain of the subterranean ants, masters of underground architecture and social organization. These ants have evolved to thrive in the darkness, navigating their elaborate nests with ease and creating complex societies that rival our own in their efficiency and division of labor. The nests of subterranean ants are often described as cities due to their complex organization and the vast number of individuals that inhabit them. These nests can extend deep underground, with interconnected chambers serving different purposes such as brood rearing, food storage, and waste disposal. The tunnels, meticulously excavated by worker ants, provide pathways for movement within the nest and for foraging expeditions to the surface. Life underground offers several advantages for ants, including protection from predators, a stable temperature, and a relatively humid environment, even in arid regions. On the forest floor, amidst fallen leaves, decaying logs, and tangled vegetation, another world of ant life unfolds. Here, ants construct elaborate fortresses utilizing natural materials and their own bodies. From the towering mounds of leafcutter ants to the delicate silk nests of weaver ants, the forest floor showcases the architectural ingenuity of these tiny creatures. In the unforgiving deserts, where temperatures soar and water is scarce, ants have evolved remarkable adaptations to survive and thrive. From their water harvesting techniques to their heat-resistant exoskeletons, desert ants have mastered the art of desert living. One of the most impressive adaptations of desert ants is their ability to navigate over long distances in search of food and water, often in the scorching heat of the desert sun. Some species, like the Saharan silver ant, have evolved a highly reflective exoskeleton that helps to deflect sunlight and reduce heat absorption. Honeypot ants, found in arid regions of North America, Australia, and Africa, have specialized workers, known as repletes, that store large amounts of sugary liquid in their abdomens. While ants may seem out of place in our concrete jungles, they have proven to be remarkably adaptable, establishing thriving colonies in urban environments around the world. From the cracks in sidewalks to the walls of our homes, ants have infiltrated our cities, exploiting the resources we provide. Urban environments offer ants several advantages, including a readily available food supply and a relatively stable climate. However, urban living also presents challenges, such as the fragmentation of habitat, the presence of pesticides, and the constant disturbance from human activities. Despite these challenges, ants have thrived in urban environments, with some species, like the pavement ant, becoming so well adapted to city life that they are rarely found in their natural habitats. While most ants are earthbound creatures, some species have taken to the skies, evolving the ability to glide through the air, expanding their foraging range and escaping predators. These gliding ants, found in tropical rainforests, demonstrate the remarkable diversity of ant adaptations. Gliding ants do not possess true wings like birds or insects. Instead, they have evolved flattened bodies and elongated legs that allow them to control their descent when they jump or fall from trees. When threatened or dislodged from their arboreal homes, these ants can glide through the air, using their bodies and legs as airfoils to steer and direct their fall. This gliding ability offers several advantages, allowing them to escape predators, quickly move between trees, and avoid obstacles on the forest floor. At the heart of every ant colony lies a figure of paramount importance, the queen. She is the matriarch, the founder, and the sole reproducer in most ant societies. Her life is a testament to biological efficiency, dedicated to the singular purpose of ensuring the colony's survival and growth through the continuous production of offspring. The queen's reign begins with a dramatic nuptial flight, a once-in-a-lifetime event where she mates with one or more males. Once mated, she sheds her wings and embarks on the task of establishing a new colony. She lays her first batch of eggs, carefully tending to them and nurturing the developing larvae with her own saliva. The vast majority of ants you encounter are workers, the tireless laborers that form the backbone of the colony. These are all females, sisters born from the queen's eggs, their lives dedicated to serving the collective. They are the builders, the foragers, the nurses, the cleaners, and the defenders of the colony, each task meticulously performed. Worker ants exhibit a remarkable division of labor, often specializing in specific tasks based on their age and size. Younger workers typically tend to the brood, while older workers venture outside the nest to forage for food, build and maintain the nest structure, and defend the colony from threats. Their lives are a testament to selfless service, their individual needs subsumed by the needs of the colony. Section 3, Guardians of the Nest, Soldier Ants. In many ant species, a specialized caste of workers evolves to fulfill a more formidable role, the soldiers. Larger than their worker sisters and often equipped with powerful mandibles or venomous stingers, soldier ants are the protectors of the colony, the first line of defense against intruders and threats. Their lives are dedicated to safeguarding the colony's safety, patrolling the nest perimeter, engaging in territorial battles with rival colonies, and repelling predators that threaten the colony's well-being. They are the guardians, the sentinels. Their imposing presence a deterrent to those who would dare to threaten the colony's security. Their sacrifice and bravery ensure the colony's survival, allowing the queen to continue her reign, the workers to perform their tasks, and the colony to thrive, protected by the unwavering dedication of its soldier caste. Section 4, Chemical Communication, the language of scent. Ants have evolved a sophisticated system of communication based on chemical signals or pheromones released from specialized glands. These scents are the language of the ant world, conveying complex messages about food sources, alarm signals, colony identity, and even the queen's reproductive status. Ants perceive these chemical messages through their sensitive antennae, which act as highly specialized olfactory organs. A single ant can release a variety of pheromones, each with a specific meaning, creating a complex chemical tapestry that permeates the colony and its surroundings. This chemical communication system is remarkably efficient, allowing ants to coordinate their activities, navigate their environment, and maintain social order within their complex societies. Section 5, From Egg to Adult, the Ant Life Cycle. The life cycle of an ant is a fascinating journey of metamorphosis and social development, transforming a tiny egg into a specialized member of a highly organized colony. The queen initiates this cycle, laying numerous eggs that hatch into small grub-like larvae. The larvae, lacking legs and eyes, are completely dependent on the worker ants for nourishment and care. They are fed regurgitated food and groomed meticulously, their growth and development carefully monitored by their worker sisters. As the larvae grow, they molt, shedding their skin several times before entering the pupal stage. Within the pupa, a remarkable transformation occurs, the larval tissues reorganizing and differentiating to form the adult ant's body. Finally, the adult ant emerges from the pupa, ready to take its place within the colony's intricate social structure. In the depths of tropical rainforests, a remarkable agricultural practice unfolds, orchestrated not by humans but by ants. Leafcutter ants, renowned for their industrious nature and impressive foraging columns, have mastered the art of cultivating fungus, creating subterranean gardens that provide sustenance for their vast colonies. These ants, unlike any other creature on Earth, have evolved a symbiotic relationship with a specific type of fungus, relying on it as their primary food source. The ants cultivate this fungus in specialized chambers within their nests, providing it with a carefully curated diet of chewed-up leaves, flowers, and other plant matter. The fungus, in turn, grows and produces specialized structures, rich in nutrients, which the ants harvest and feed to their developing larvae. This mutually beneficial partnership highlights the remarkable complexity and interconnectedness of life in the rainforest, where even seemingly insignificant creatures play vital roles in maintaining the delicate balance of the ecosystem. The agricultural prowess of leafcutter ants is a testament to their sophisticated social organization. They manipulate their environment to meet their needs. Their foraging columns are a marvel of efficiency. Ants of different sizes work together to harvest and transport leaves. Larger workers cut and carry large leaf fragments. Smaller workers ride on the leaves, protecting their larger sisters from parasitic flies. Inside the nest, leaves are processed by workers who chew them into a pulp. This pulp is used to cultivate fungus, providing food for the colony. In the arid deserts, where food and water are scarce, honeypot ants have evolved a remarkable adaptation to survive. They have turned some of their own workers into living reservoirs, storing sugary liquid in their abdomens to provide sustenance for the colony during times of need. These specialized workers, known as repletes, are a testament to the extreme lengths to which evolution can go in shaping life to survive in challenging environments. They gorge themselves on nectar, honeydew, and other sugary liquids, their abdomens swelling to many times their normal size, becoming living storage tanks for the colony's precious resources. When food is scarce, other ants in the colony can tap into these living reservoirs, stroking the replete's antennae to stimulate them to regurgitate the stored liquid. This remarkable adaptation ensures the colony's survival through periods of drought or famine, showcasing the incredible diversity and adaptability of ant life on Earth. Section 4. The Army Ants March, a Force of Nature. In the tropical rainforests of Africa, Asia, and South America, a formidable force of nature marches across the forest floor, the army ants. These nomadic ants, renowned for their aggressive foraging behavior and massive colonies, are a spectacle to behold. Army ants form temporary bivouacs, living walls of ants linked together to protect their queen and brood. Their foraging raids are a relentless wave, overwhelming and devouring any insects and small creatures in their path. Section 5. Communication beyond scent, vibrant signals. While chemical communication through pheromones is the primary mode of communication for most ants, some species have evolved additional, more vibrant signals to convey information and coordinate their activities. These signals, often involving sound and vibration, add another layer of complexity to the already sophisticated communication networks of these fascinating insects. Some ant species, like the carpenter ants, communicate by drumming their bodies against the substrate, creating vibrations that travel through the nest structure. These vibrations, known as stridulations, can convey information about alarm, food discovery, or even the presence of intruders. Other ants, like the leafcutter ants, use a combination of chemical and vibrational signals to coordinate their foraging activities. As they cut and carry leaf fragments back to the nest, these ants produce stridulations that help them to maintain their spacing and avoid collisions, ensuring efficient transport of their precious cargo. Section 1. The Unseen Influence. The world of ants, though often hidden, exerts a profound influence on ecosystems. These tiny architects play a crucial role in maintaining the balance of life on Earth. Their foraging activities enrich the earth and promote plant growth. As seed dispersers, scavengers, and predators, they regulate plant and animal populations. From forests to urban jungles, ants shape the world around us in countless ways. Section 2, a world within our own. The study of ants offers a glimpse into a world of complexity and wonder, a world that exists parallel to our own, yet often goes unnoticed. Their intricate societies and remarkable adaptations fascinate scientists and nature enthusiasts. As we delve deeper into the world of ants, we gain a newfound appreciation for the interconnectedness of life on Earth. Their story is a reminder that there is still much to discover and protect. So the next time you encounter an ant, take a moment to appreciate these tiny wonders.